Hi everyone, welcome to lesson 15.4 part 2. So yesterday we talked all about rectangles and rhombuses, and today we're going to talk about specifically properties of squares. You're definitely going to want that notes handout handy or a notebook to take some notes in, a pencil, possibly a highlighter, and a calculator. So on the note sheet, we see here the definition of a square, and a square is special because it's not only a parallelogram, but it's a parallelogram with 4 right angles and 4 congruent sides, which may seem familiar to you from the last video, because basically what's happening is our square is the combination of both a rectangle and a rhombus, right? So it's basically got the properties of all 3. So it's a rectangle with 4 congruent sides, like the rhombus, or you could call it a rhombus with 4 right angles, like the rectangle. So again, it has the properties of all 3 of our previous figures because it's kind of a combination of all of the above. So what that means is everything we've talked about over the past few lessons with parallelograms, rectangles, and rhombuses are true for a square. Okay? So if we look here in example 1, we're given that this is a square, SQAR. And we want to find x if SUQ, this angle, is 10x. Well, we know that not only with the rhombuses, but now with a square, the diagonals are perpendicular in this specific figure. So what we know here is that 10x has to equal 90 degrees. So x has to be 9. Right, our next example then, on the back of the next page, is looking at, again, square, SQAR. And what we see here is this time they're talking about angle SRA. Well, this is that angle of a square that is similar to the property of a rectangle, that the angle has to equal 90 degrees. So we set this equal to 90, subtract the 6, and divide by 3. We get x to be 28 on this particular problem, which is where we can stop. Next, in example 3, we have, again, square. This time we're talking about sides, though, or in the segments here of the diagonals. They're giving us SU and RU, right, is what they're talking about. Well, just like our rectangles, we know all 4 pieces of the diagonals, the baby pieces, are all equal to each other. So if we know SU and we know RU, we know that the values are equal to each other because the diagonals are congruent. So if we subtract the 4x and then subtract 3 and divide by 3, we get x to be 6. So now we have to be careful, though, because we need to plug this back in. So we have that our final answer wants us finding QR. Well, QR is this angle, right, or this whole segment here. So if we plug back into RU, 7 times 6 plus 3 is 42 plus 3, which is 45. But to get the whole piece RQ, or QR, we have to add up 45 twice so that it would be a length of 90. Okay. Now, the next one then is asking us to look at the diagonals SA and RQ. Well, again, just like we know the little pieces are congruent, we know the big diagonals are equal to each other as well in a square because that's the property of a rectangle. So if we add the x to both sides here, we get 5x, and then we're going to have to add the 60 to both sides. We would end up getting that 5x equals 90. And if we divide by the 5, x is going to be 18. Which is what we're trying to find. Our final example then for example 5 is asking us to look at sides. SQ, which is 2x minus 4, and QA, which is 18. We know all 4 sides of a square, just like the rhombus, are equal. So 2x minus 4 equals 18. Add the 4 to both sides, we get 2x equal to 22. X has to be 11, and that's what they're asking us to find, so we are done there. So the square is a combination of the rectangle and the rhombus. So notice in our square it has the 5 characteristics of a parallelogram. It's also got the characteristics of a rectangle, diagonals congruent, and all angles equaling 90. And then finally, it will have all of the characteristics of our rhombus as well. The diagonals are congruent. All 4 sides are congruent. So diagonals are perpendicular. And then the diagonals bisect each other, aka they cut it in half. Okay. All right, we will work more with all of our parallelogram family members in class. Thanks for watching.